How embarrassing. Goodness gracious. All right, I'm going to speak about the new soil food web. The soil food web has been around for a long time. Let's see. I call myself Lord of the Roots because I had 3 books. Then I did a 4th one, which is now a tetralogy, but I still call myself Lord of the Roots. And then I have a 5th book called Auto-Flowering Cannabis. And if you don't know about auto-flowering cannabis, this is what you should be growing. Auto-flower hemp, small plants, 2 tons more per acre. Unbelievable, everybody's using them in the United States. This is designed for you. We can talk about that maybe next year. Well, it's great to be here in Iceland. What a beautiful place. Oh, wait a minute. These are pictures from my bedroom window in Anchorage, Alaska. So I feel pretty comfortable. Let's get down to business. This is an Alaskan sled dog doing his business. When I first started gardening, everybody had a phone that was attached to the wall. When you moved out of the house, the phone stayed there. There were lots of gardening magazines, tremendous number of magazines. Aluminum foil was invented. Plastic was invented. We ate plastic. We played with plastic. We had new special fertilizers. We learned how to spray our food. Today, this is our instant coffee. Oh, instant coffee was invented, I guess. And we had a TV show in the United States called Better Living Through Chemistry. And it was a doctor with his little student. Of course, she grew up and understood the chemistry. Today, this is our popcorn, no aluminum foil. This is probably how you eat when you want to eat quickly on the cheap. This is our instant coffee. We all own our own telephones. We carry them around in our pocket. And when we want information, we can get it anywhere we want. And we do. This is what they have in the airports today. So it's 2024. We're still using, a lot of people, the same old fertilizers. We're still spraying food. We're using glyphosate, which is even worse. We're stuck. And why are we stuck? It's just so silly. It's just one of those things. This is one of the reasons in the United States why we're stuck. There's this Scottish guy who comes on every spring and yells at us that we need to be using Miracle-Gro and putting it on our lawns with all the chemicals that are in it. I used to believe Miracle-Gro was great. Nitrogen was nitrogen. It didn't matter whether it came from a green powder or whether it came from a brown manure. It was nitrogen. And then I learned about the soil food web, and I could give the whole lecture off this slide. I won't. What happens is you get the sun's photosynthetic energy. About 60% of that is used by the plant to produce exudates, which are dripped out of the root system of the plant, and they attract bacteria and fungi, who then attract other things that eat the bacteria and fungi, poop out the excess, which is plant-usable food. This is a root. These are the exudates, that blue coming out of the root. Let me show you how it works. This is pretty easy. So you got these trees that are sitting in front of some church here in town, they decide they've been guarding it all week long. They want to go out for dinner, and one wants Japanese, and one wants Mexican, and one wants French. The Japanese one's biggest, so it wins. And sure enough, these are the roots. What they do is they put out an exudate. Put the roots that way. They put out an exudate. The exudate comes into the soil, and it attracts Japanese bacteria. Simple as that. And if they wanted something else, they could change the mix. If they wanted American food, they just change the exudate, and the next thing you know, they have American food. The plant is in control. We like to think we are, but if you leave it alone, the plant is in charge. All right, let's talk about the soil food web itself. The development of the soil food web started in about 2000. My first book came out in 2006. We called it Microbe-Mediated Solubilization of Soil Nutrients, aka the poop loop. Now, you have all of these bacteria that are attracted to the plant. The second is fungi that are attracted to the plant, special mycorrhizal fungi. They form what's known as the fungal loop. And the way the fungal loop works is that the root goes into the soil. There's a depletion zone around the root, and the plant calls mycorrhizal fungi to it. They associate with the root, and they go out into the soil, into areas where the root is too big to reach, and they extend the reach, and they bring back all sorts of nutrients to the plant, and they feed the plant. So this is kind of the way it works. You've got two seedlings sitting out in the sun. One of them says, geez, I'd really like I'd like a bologna sandwich. And so what does it do? It prepares the right exudate, gets all the ingredients, puts the exudate out into the soil, and the next thing you know, it catches a fungus, and the fungus provides the bologna sandwich to the plant root. And what's really cool is that once they've made their establishment with the root, these fungi continue to stay there, and they continue to feed the plant, which is kind of a neat thing. And what's even neater is that they'll share with other plants. So you might have a row of marigolds, and half of them are in the sun and half of them are in the shade, but they all look the same. It's because of the mycorrhizal fungi down at the base feeding the plants. All right, so 3 ways plants get nutrients. Let's talk about the bacterial loop first. I guess I'm going right on to the bacterial loop, and then we'll start with what's known as the rhizophagy cycle. Now, this was discovered in 2017, and I bet you most of you have never heard of the rhizophagy cycle, and yet it's incredible because it can provide up to 40% of a plant's nitrogen. None of us knew it existed. A bunch of students down in Australia made the discovery. What they thought they saw were cells in the roots opening up and eating these bacteria. Now, when I say bacteria, you might be thinking of a bacteria like one bacteria. You never think of bacteria as just one. There's gazillions of them all over the place, as you can well imagine. And they breed like crazy. Every 20 minutes they multiply. This is the tip of a pin with bacteria on it, so you get a feel for how small they are and how many there are. This is your tongue, and these are all the bacteria on a single cell in your tongue. So we all know about nitrogen-fixing nodules. You can buy a powder, you can put it down on your seeds or in your roots, and you can get nitrogen fixation on legumes. They form these little nodules, and they fix nitrogen in the nodules. Bacteria can enter a plant through the root system, and they can enter it through the stomata. That's a picture of the stomata. Those little round things around it are the bacteria. And they move into the plant, and they spread themselves throughout the plant. Now, rhizophagy, on the other hand, it doesn't go through the leaf system. This is a system that goes through, I keep emphasizing it, the exudate goes out, and it attracts all of these little white things there. Those are bacteria. Here's a better picture of the bacteria using new kinds of microscopes that we have, and you can see all of these bacteria at the root tip. What happens is they smell a smell that's like popcorn, and it literally causes them to think that there's a place for them to go and live. And so they back into that area. It smells like popcorn. And the next thing you know, they bust through the cell wall of the root down in a meristem cell. And they end up in a place called the periplasmic space. It's a little space just inside a cell wall before you get to the cytoplasm. So it's got this little area that goes all the way around the plant. I think the best way to look at it is to think of a tofu container. Okay, so the white on the outside, that's the cell wall. The liquid on the inside is that endoplasmic space, and you get circulation in that liquid. And then, of course, you get the tofu, which is the cytoplasm, the stuff that's inside the cell. These are bacteria inside a plant root cell, and you can see all these cells have bacteria in them. What happens is the bacteria go into the plant. The plant goes, uh-oh, bacteria attacking me, and it sprays the plant with something called a reactive oxygen series, or a ROS. And the ROS strips off the cell wall. It strips off just the cell wall, but it doesn't take the rest of the cell. This is the same thing that happens when you get a sunburn. There's a ROS inside your skin, and it causes that sunburn. I even found a Ross with a sunburn, which I thought was... Okay, so the bacteria have their cells, the walls, stripped off of them by this Ross. Now, the bacteria go, wait a minute, I'm getting attacked. And so what do? They fight back. And they fight back in two ways. The first is by putting out ethylene. So bacteria can produce ethylene. They put ethylene out into the cell, and that causes the cell to grow and to stretch. The second thing they do, and it causes carbonic acid to be formed, which weakens that Ross so that the bacteria can assume that they're going to be able to live. So it stretches that cell out. You add a little bit of carbon, and it does some great stuff for the plant. It also, in order to protect itself, produces nitrate inside the plant cell. This is what nobody knew. 40% of a plant's nitrogen comes from these bacteria working the rhizophagy cycle. So they put the nitrous oxide out. It gets converted into NO3, which again weakens the Ross. So you've got this little system going on. You've got a couple of loops going on inside the cell. And again, nobody knew these existed until 2017. And it wasn't until a couple of years later that a gentleman at Rutgers, New Jersey, University of Rutgers, discovered what was really going on. So again, the plant eats the cell wall and takes those nutrients, there's a lot of metals, a lot of good stuff in it, and uses it. And then these bacteria continue to circle around the cell in that endoplasmic space. And so they go around and around, and they multiply and they multiply, and they get more crowded, more ethylene. This is a cell. You can see all those little things around the cell. Those are all bacteria. And eventually what happens is they've got their wall missing. They form these little quads, and they continue to grow, continue to multiply, continue to circulate, and bigger. And eventually what happens is you get so many of them that they are pushed up against the cell wall. And when they push up against the cell wall, they cause the cell wall to form a little tube. You and I know this tube as a root hair. Root hairs are formed by these rhizophagy bacteria that move into the cell, multiply, put out the ethylene, and then push their way through the cell and out the cell. And so what you can see here are these root hairs, and they're all filling up with bacteria, which continue to multiply. So you get a lot of root hairs, you get a lot of bacteria. You can see why 40% of the nitrogen might come from there. This is one of those root hairs. The bacteria is moving into it, and it's been dyed so you can see the activity. And what happens is it goes to the tip. A small tidal wave literally goes through the root to the tip, and there's a bunch of them in the air, and it blows the bacteria without their walls into the soil again. So these are the pictures of people have taken of bacteria being blown out of root tips, of root hairs, and it can happen as the root grows. You get 1, 2, 3, 4, maybe 5 different explosions of these wall-less bacteria that get thrown back out into the soil, and when they're in the soil, they grow their wall back again. And then 2 days later, they find themselves back inside a root cell. So what are root hairs doing? Root hairs are putting bacteria back out into new soil where they can get the nutrients they need to grow their cell walls so that they can travel back in and continue to feed the plant. It's a wonderful cycle. It's called the rhizophagy cycle. This is a good diagram of it. It's been proven, no question about it. And again, probably 10,000 people in the world have any idea this exists. It's one of the fastest growing the fastest growing facts about plants that people have just started to really go on. So under the old system, where you have the poop loop, where you've got things that are eaten, pooped out, they're in plant usable form, they go into the plant and feed the plant, the plant's sort of a farmer. In this system, the plant's a rancher. So it puts the sheep out, it brings them back in, takes the wool off, uses the wool, maybe eats a lamb chop or two, and then puts the rest of them back out in the paddock so that they can regrow their wool and be used again. So this is a kind of a new thing. Now, when those root hairs form, little cracks occur on their edges. And some of the bacteria that would have gone into the root through the meristem cell actually sneak in and go into the root through those little areas. And they're in the root, and they produce phytohormones. These are things that make plants do what plants do. So you get, well, you can read as well as I can, but all the things that plants do, germination, dropping leaves, fruit formation, flowering, all of these things are caused by phytohormones, some from the plant, but a lot of them from these bacteria, and no one had any idea. Then what happens is they work their way up into the flower, and when they're in the flower, they get trapped as the flower forms the seed. So that when the seed is put into the ground, it has the right kind of bacteria. They jump off the seed or out of the seed, and they're in the soil where they multiply so that they can then feed the plant. They've done experiments with corn. They took a 400-year-old variety of corn, and they discovered that the bacteria has remained the same for 400 years. And this is why. Because they go into the seed, and then they jump out of the seed, and they continue this cycle. Unbelievable. And once these bacteria go into the plant goes, ooh, I'm being attacked, and it sprays the ROS, does all of those other things, but it makes the plant more resistant because it has to be able to withstand the ROS that it's putting out there that's trying to strip the walls off of the bacteria. And so in order to be able to withstand the ROS that it's producing, it has to get stronger. And it develops abiotic stress resistance to heat and cold and drought, and biotic stress resistance to all sorts of organisms that would fight it. And this all occurs as a result of the rhizophazy cycle. Now, you can buy certain bacteria that seem to help the rhizophazy cycle. And if you're going to take a picture of anything, this is the one to take a picture of. These are all relatively, you can get them. I think the methobacteria down at the bottom is a little bit difficult because you have to freeze dry it, but these are all available for people to use to grow hemp using the rhizophazy cycle at its top. So there are some obvious takeaways from this stuff. The first is that the plants are in control. We like to think we're in control, but we just mess stuff up. When you throw a Miracle-Gro fertilizer on a plant, all sorts of things happen. The plant says, wait a minute, I'm getting free food. Why do I have to use my energy to develop my own food? So it stops. It stops attracting mycorrhizal fungi. It slows down this rhizophazy cycle, if it even occurs at all, because the bacteria may not like the particular food that's being put down there. So the plants are in control, and to the extent that you're able to let a plant do its thing, you should. They're really, really incredible. These bacteria, by the way, are gorgeous. Look at some of these bacteria. Oh, God. Chemicals definitely have a negative effect on these bacteria. And because these bacteria are inside the plant, they're known as endophytic bacteria. And so if they're inside the plant, got to be careful. You want to use organic materials so that you don't impede their growth, their multiplication, and their ability to move into the root. So we don't use chemicals at all. We don't use pesticides because you don't need to, because the plant's allowed to develop its own stress resistance. And then, of course, there's all sorts of things in the soil food web that are there to eat bacteria and fungi. They run around the soil either in adult form or in larva form, and they create soil structure. The bacteria produce a slime which causes little individual particles of soil to stick together. And then these guys, and the fungi then wrap around those and make bigger aggregates. And then these guys run around making holes, and air can go in, and water can go in, and reservoir spaces, and all sorts of good stuff as part of the soil food web. So When you use chemicals, you break up the nitrogen fixation situation that naturally occurs in the plant. You do away with the mycorrhizae, the partnership between fungi and plants. And you end up with all of these terrible things. And so then you go to the store and you buy a chemical to try to cure your problem, and you only make it worse. So there are certain best practices that you need to use if you're going to use the soil food web. The first is that you have to feed the soil. There's something known as the law of return. What falls down from a plant is supposed to fall down from that plant so that it can then decay or be decayed, and the nutrients that are in that material go back into the soil and re-feed the plant. Now, we come along as hemp farmers and we remove stuff. So that means the soil doesn't get what it needs because you're taking it away. So you need to add good organic materials, wood mulches, compost, soybean meal. There are all sorts of things that you can find that are organic that will feed the soil food web. You need to test. You need to test to know whether your soil's any good. And there are all sorts of standard tests which you know about, which can tell you NPK, but there's a new test. It's called the microbiometer. And you should take a look at that later on the internet, www.microbiometer.com. What you do with the microbiometer is you take a small sample of your soil, you put it through this little kit, and then you take a picture of it with your phone. And it tells you the microbiomass of your soil. Microbiomass, how many microbes are in your soil. It matches or it correlates with nitrogen, which is the key element that plants need. And so if you have a high microbiomass, you don't need to feed your plant. If you have a low microbiomass, you do. And using the microbiometer, you can tell whether what you're putting on your plant is increasing the biomass or whether it's decreasing the biomass. So you take a test at the beginning, and then you take a test a couple of weeks or a month later, and you see what's going on with your soil. It's really a neat new instrument. And again, very few people know about it, but it is wonderful. Don't disturb the soil. No more rototilling. Rototilling is a big no-no because it breaks up everything in the soil. So if you have a worm in the soil and you rototill the soil, it cuts the worm in half. You don't end up with two worms. You end up with two dead worms, or two halves of one dead worm. When you rototill, you break up the fungal biomass that's throughout the soil. And when you break that up, then you're interrupting the system, both the poop loop as well as the mycorrhizal loop, and so you have to wait for them to get back into shape again, and that's maybe too long. Your plants may be gone by then. So you don't till. And when you plant, you don't need to take a whole garden and rototill the whole field. A little teeny row about this thick is all you need. You could take a 2x4 and run it down the whole farm and just plant in that little furrow. The rest of the soil is fine. We all have seen dandelions growing through cement. These plants can take care of themselves. We baby them way too much. All right, this is the microbiometer kit itself. It's a little kit, comes with about 10 or 15 little tests in it, and that's how you use it. You just put that little drop there and your cell phone tells you what's going on. So, because of the rhizophagy cycle, we now know that you shouldn't sterilize seeds. Well, lots of people who grow hemp take the seed and they sterilize it. Why? Doesn't make any sense to do so. They also maybe would start seeds inside a paper towel. If you're going to do that, the bacteria jump off the seed when it germinates and goes into the paper towel. So plant the paper towel with the seed so that the right bacteria are there. Don't rototill. Don't throw away old soil. Too many people who grow hemp just start fresh every single time. The soil that you just grew a plant in has the bacteria that were on that hemp plant in that soil already. They may be dormant. They'll wake up when a new plant gets in there. In addition to which, the root systems that are in that soil already can be very effective for two reasons. One is they provide organic material as they decay, and two, they tend to act as channels which the new roots from a new plant can grow through. So if you're growing in pots, in a greenhouse, for example, you cut the plant, when you harvest it, just plant a new plant in there. And if you got questions about whether the soil's any good, you just use the microbiometer test. And then compost, compost, compost. It's got the stuff that you need. It has all of the bacteria and all of the fungi in it. It's got all of the nematodes and protozoa that eat the bacteria and fungi and poop them out. So it's really just the best stuff you can possibly use. And if you use compost, you don't need anything else, really. You can use the compost, the best compost is from the same plants that you're growing. It works great, and of course, vermicompost is terrific. I don't know what your worm situation is. Here in Alaska, we didn't have worms until about 15 or 20 years ago when they came in pots and in bags of soil that people were buying at nurseries and whatnot. You have to be very careful to make sure that you're getting the right kind of worms. And if Iceland doesn't have a big worm population, you really need to pay a lot of attention to it. Because if you get the wrong worms, and there's now a worm that comes from Asia that eats through the duff so quickly that it's taking forests out. So it's preventing mycorrhizal associations from forming. And so you have to be very careful about what kind of worms you use. Red wigglers are the right kind. Not so obvious takeaways. The first is to read the books. Simple as that. These books will tell you exactly what you need to know. They're on science, but they're not very scientific. I like to say they're very easy to read. And you can listen to them now as well. And if you happen to, speak Turkish, they're in lots of different languages, so you can, not in Iceland yet. All right, so I always tell people, if you're not convinced, just think about this. Oh, let's see, I didn't have the slide. You look at the trees in your natural forests, and they're beautiful. Who's feeding those trees? You look at the redwoods in California. They're the biggest trees in the world, and they've never received a single drop of Miracle-Gro, no fertilizer whatsoever. How did that happen? It happened because they produce exudates that attract bacteria and fungi, that attract nematodes and protozoa that eat the bacteria and fungi and poop out the excess. They attract mycorrhizal fungi, and even though they may be 550 years old and 600 feet tall, they have rhizophagy bacteria throughout their root systems. It's really so simple. It's so easy. If we just let plants be themselves, they do what they're supposed to do. So that's the talk. I urge you to get the books. And one last thing, if you're growing anything, you should always have one little row in your farm or in your garden to feed the hungry. So that's an important lesson. All right, that's it, folks. I'm ready to take some questions.
Yeah, do we have any questions for our guest? I'm going to get a microphone for us.
Yes? No? Yes.
Let me see if I know how to turn this on. Hallå. Virkar den? Ég alveg sko afleitt í svona. Okay,
Okay, thank you. Thank you for your presentation. It was impressive. And I just wanted to ask, because in cannabis, especially in the medical cannabis world, there is a lot of cultivation in the indoor, but mostly in these, like rock wool, hydroponics.
Yes.
So I wanted to ask you, what's the difference if you, on the plant and its quality, especially for these cannabinoids? I don't know if you studied that deep, but I imagine that these has some big difference, and I don't just understand how this can affect like the way of cultivation, the quality of the plant.
What you're asking is there a difference between hydroponics and soil food web soil?
Yeah.
Basically. And there is a difference. So when you use that rock wool will attract bacteria and fungi and hold it, but not as many. And you're feeding the plant a chemical. And so that sort of takes the plant into a different realm. If I had my preference, I would grow in soil for medical cannabis rather than hydroponics. Hydroponics really came into use with regard to medical cannabis because it was easy to do in a closet. You know, you could hide it. Nobody knew you were there. You really want to use soil if you can. It's much better.
For the quality of the plant.
For all plants.
Yeah, but like my question is really like how it can affect the quality of the like plant final product. Like, it can be there any different?
You mean how do you improve the final product? When you use the right soil food web materials, the plant produces the very best product it can. Simple as that. It's when you start using things like Miracle-Gro, and again, I hate to pick on it. The reason why I pick on Miracle-Gro is because the guy who invented Miracle-Gro worked with my father and grandfather in the butter business, and he hated it. But while he was there, he put my picture on a margarine package, and it's still there. So I'm the only one that's allowed to badmouth Miracle-Gro in the entire world. Otherwise, they'd sue us. But yeah, you use a chemical, and you can taste it. You can taste it in the medical cannabis that you might be growing. There's a distinct difference. And there have been lots and lots of tests done in the United States. It used to be, of course, that hydroponics was the only way to go. I used to give this talk on soil food web, and people would go, hydroponics. And now everybody's gone the other way. So it's soil now. I understand it's not the easiest sometimes, but it's the best.
Thank you.
Now, if you're going to grow hydroponic, use the rock wool and try to use organic inputs. The problem with doing that is that you've got to clean your system. You get bacterial slime, and that slime has anaerobic, produces alcohol, which kills roots and stuff, so you have to be careful.
It could be like aquaponic, maybe also.
The aquaponic is much better, yeah.
Do we have any other questions?
Don't be shy.
Yeah, well, I have a question here. So,
Do you want to use the microphone, please? Can you hand it back? Thank you.
so thank you very much. Thank you for a very interesting lecture. A lot of things to be learned there from my side. Yeah. So one of the things you're talking about medical cannabis now, and one of the things for medical cannabis is that things need to be consistent. It needs to be the same growth after growth after growth after growth. So can you do that in soil?
Absolutely. Oh, absolutely. No question about it. You know, most people, I have a place, I spent a lot of time in Oregon, and so I know a lot of growers down there. Alaska's a little bit different, but everybody's using soil. Everybody. Hydroponics is definitely on the outs. And when you go on the internet and take a look at the big cannabis farms in the United States and California, they're all soil. They're all soil. So if you can make that conversion, that's really the best way to go, and you end up with very consistent, the genetics of the plant that can come to fore as a result of having the best possible system, which is the soil food web system. So it ends up that if you use the same seeds all the time, you get the same cannabis, same numbers all the time.